Welcome back. Bismillahir Rahmanir Rahim. Today we will discuss about the chemical properties of furan. Usually, furan taking place electrophilic substitution reactions. As you know, electrophilic substitution reaction is the attack of the electrophile on the pi electron system. So, the electrophilic substitution reactions in heterocyclic compounds, particularly furan, taking place in the same manner as occurs in other simple aromatic hydrocarbons like benzene. तो जिस तरह की बेंजीन में इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन आकर करता है इन द सेम सेंस फ्यूरेन में भी इसी तरह आकर करता है. सो इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन इसमें कोई शक नहीं आकर करता है फ्यूरेन के अंदर, लेकिन विच पोजीशन विल बी मोर अवेलेबल फॉर सब्स्टिट्यूशन. So if we broken down the bond in this direction, the electrophile this position will become negatively charged and the electrophile will attach itself at this position. Now we can draw another resonating structure of this. How as you know that this position have a positive charge, so these lone pairs of electron will form a bond with these positions, and as a result oxygen will become positively charged. Now we only have two resonating possible structures if electrophile attack at position number 3. So this is position 1, 2, 3, 4, 5. So on attacking of the electrophile on position number 2, there are two possible resonating structures. Similarly, if the electrophile, the bond is broken down in this direction, and after attacking of the electrophile and the pi electron system in this direction, the electrophile attach at position number 2, and we have another resonating possible structure. This bond is broken down in this direction, so pi bond and positive charge will come here, and then here we have lone pairs of electrons. The lone pairs of electrons will attract it towards the positive charge, another bond is formed and oxygen will become positively charged. So in this case we have 1, 2 and 3 possible resonating structures when an electrophile attack at position number 2. As in case 2 we have more resonating structures as in case 1. This mean ke a compound that produce more resonating structures will be the more stabilized form. So electrophilic substitution reaction, electrophile when attack at position 2 will be more stabilized as compared to attacking up the electrophile at position number 3. This shows that during electrophilic substitution reactions of furan, electrophile will attach itself at position number 2 and position number 4. Position 2 and position 4 क्योंकि position number 3 पे there is a lack of electron density position 3 पे भी कम है, और position number 4 पर भी 5 पर भी positive charge है, तो position number 5 भी जो है वहाँ पे भी electrophile attach नहीं कर सकता, और position number 1 also possess positive charge, तो position 1 पर भी electrophile जो है attack नहीं कर सकता. It means that position 2 and position 4 are more feasible for electrophilic attack. This shows that if the position 2 and position 4 are already occupied by any other electrophile, then position 3 and position 5 may also attach electrophile. So position 3 और 5 पे सिर्फ उस सूरत में electrophile खुद को अटैच कर सकते हैं जब हमारे पास पोजीशन नंबर 2 पे और पोजीशन नंबर 4 पे ऑलरेडी जो है कोई इलेक्ट्रोफाइल मौजूद हो, तो फिर 3 और 4. वरना इन नॉर्मल सिचुएशन पोजीशन नंबर 2 and position number 4 is favorable for the attack of electrophile. Now this is the electrophilic substitution, general patterns of electrophilic substitution reaction. Now we will discuss the different kinds of electrophilic substitution reactions. One of them is sulfonation. Number one is sulfonation reaction. Sulfonation reaction. Sulfonation reaction. You know that the addition or the introduction of the sulfonic acid group into the furan ring is known as sulfonation reactions. Here you can see this is furan, and after adding sulfuric acid into the ring, this will be possible to attach what? To attach HSO3, SO3H. So this is the sulfonation reaction. Sulfonation reaction and adding sulfuric acid with furan results the formation of furan sulfonic acid. So this is said to be as the sulfonation reaction because of the introduction of the sulfonic acid group into the ring is known as sulfonation reactions. Now we will discuss the mechanism of the sulfonation reactions. This reaction taking place in another molecule of sulfuric acid that is acting as a catalyst. Now we will discuss the mechanism of sulfonation reactions. It's very easy. Already have discussed during the electrophilic substitution reactions of benzene ring. The mechanism in the very first steps, as we know, H double bond is OH and OH. So this is the sulfuric acid, and another molecule of sulfuric acid will replace one of the protons, one of the OH group. Okay, so sulfur will become positively charged, so SO3H positive. We will get SO3H positive and plus OH negative. Now this SO3, that is sulfonic acid group, will be acting as an electrophile. Now the electrophile, that is SO3H positive, will attack on the pi electron system, and we have already discussed position number 2. This is position 1, this is 2. Position 1 is more favorable for the attack of the electrophile. So as a result, the electrophile SO3H group will attach itself at position number 2, and as a result this position will become positively charged. Now in the next step is, you know that this is one of the proton replaced from this, so SO4 HSO4 negative. So HSO4 negative, which is acting as a base, will take up a proton. This will take up a proton from this carbon atoms. So HSO4 negative, H positive will yield H2SO4. So it is acting as a catalyst, and catalyst remain unchanged, and we will the pi electron system जो है वो क्या हो जाएगा, restore हो जाएगा. Sorry to say, the proton will be given out. Here we already have a proton in this position, have positive charge. Proton will be given out from this position. So after taking up a proton by this carbon, so this position will become negatively charged and adjacent carbon have positive. So pi electron system will be recovered, SO2 will remain substituted, and HSO4 will be. So this is said to be as sulfonation reactions, mean addition of electrophilic substitution of sulfonic acid group with the ring. इसके अलावा हमारे यहाँ और भी बहुत सारे सब्स्टिट्यूशन रिएक्शंस जो है वो कैरिड आउट करते हैं। उसमें बाय द सेम सेंस मैं सारों को के मैकेनिज्म्स को डिस्कस नहीं कर सकता, लेकिन इसमें है, हाँ इसके साथ है दूसरा रिएक्शन जो है दैट इज फ्रेडल क्राफ्ट रिएक्शन। फ्रेडल क्राफ्ट alkylation and Friedel-Crafts acylation reactions. You know about the Friedel-Crafts reaction. Friedel-Crafts reaction is also an electrophilic substitution reactions, and this reaction is the introduction of the alkyl group into the ring, or the introduction of the acyl group into the ring is said to be as Friedel-Crafts alkylation or acylation reactions, and usually such reaction taking place in the presence of Lewis base that is acting as a catalyst. So in this case, in case of furan, Friedel-Crafts alkylation reaction doesn't taking place. फ्यूरेन में जो है, ये मैं बता दूं, जो अल्काइल ग्रुप है अगर आप इंट्रोड्यूस करना चाहें तो अल्काइल ग्रुप जो है ये रिएक्शन पॉसिबल नहीं है, पॉसिबल है बट it results the formation of a polymer, so polymer को फिर हम नहीं include करते, so that's why Friedel-Crafts alkylation is not possible in case of furan. अलबत्ता Friedel-Crafts acylation reactions में आकर in case of furan, तो furan के अंदर जो है acylation reactions carried out हो सकता है. So if we carried out the अगर हम असाइल ग्रुप ऐड करना चाहें तो हम आसानी से ऐड कर सकते हैं CH3 C double bond O OCl. Let's suppose this is acyl halide and the reaction taking place in the presence of FeC3 as a catalyst, so this bond will be broken down in this direction, and this bond will be broken down in this direction. So as a result, C will become positively charged, this position have negative charge, so the acyl group can be introduced into the ring. So this is called, this is known as Friedel-Crafts acylation reactions. Similarly, we also the Friedel-Crafts acylation के अलावा nitration reactions भी carried out कर सकते हैं. The introduction of the nitro group into the ring is said to be as nitration reactions. इसमें देखें, this one is a furan, and if we add HNO3, so HNO3 will provide a nitro group, and that may be introduced at position number 2 into the furan ring. Such reaction is said to be as. अगर हम इलेक्ट्रो मैकेनिज्म देखना चाहें तो मैकेनिज्म will be taking place at the same as in other. देखें, HONO2 plus H और OS double bond O double bond OH. ठीक है. So this bond will be broken down in this direction, this will be broken down in this direction. HO negative, H positive will yield H2O, and NO2 positive, this will be acting as a nitrating agent or electrophile, and we will get this one is HSO4 negative. HSO4 negative. Now in the second step क्या होगा कि यही इलेक्ट्रोफाइल जो है that is NO2 positive, यही इलेक्ट्रोफाइल जिसे नाइट्रो ग्रुप कहते हैं, that will attack at position number 2 of the pi electron system and will attach itself at position number 2. As a result, this position will become positively charged. While in the next step जो है ये जो NO2 and this position have positive charge, HSO4 negative will take up a proton from this position, and as a result the pi electron system will be restored, nitro group will attach, and HSO4 H2SO4, which was acting as a catalyst, will be recovered. So this is said to be as nitration reactions. इसी तरह से जो फ्यूरेन के अंदर अदर रिएक्शंस भी डाइएल्डर रिएक्शंस भी कैरिड आउट करता है, मर्क्यूरिएशन रिएक्शंस, रिएक्शन विद ग्रेगनार्ड रिएजेंट्स, इसी तरह से ग्रेगनार्ड रिएजेंट्स के साथ भी ये रिएक्ट कर जाता है, और अलावा इसके रिंग ओपनिंग रिएक्शन, और these are the different kinds of reactions that taking place, and inshallah we will discuss such reactions किसी दूसरे मौके पे इन रिएक्शंस को डिस्कस कर लेते हैं। लेकिन इससे ये है कि इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शंस का वंस आप किसी एक के लिए मैकेनिज्म समझ जाते हैं तो फिर बाकी अदर्स के ऊपर भी यही मैकेनिज्म अप्लाई कर सकते हैं। थैंक यू।